Hi, this is question 7 from the AQA FP4 June 2009 exam paper. In this question we're told that a 2x2 matrix M has an eigenvalue of 3 and it's got a corresponding eigenvector of 1, 2. It has a second eigenvalue of -3 with a corresponding eigenvector of 1, 4. Just to remind ourselves of what this means, this particular transformation matrix is going to be stretching in the direction 1, 2 by a factor of 3, and it's also going to be stretching in the direction 1, 4 by a factor of -3. We can write this in diagonalized form of M, where we use M is equal to U, D, and the inverse of U. So first of all, we want to write down the suitable matrices D and U and the inverse of U, and then we're going to determine what the matrix M is. Okay, so for part A, we're first of all going to find the diagonal matrix of eigenvalues. So I can say that D is going to be equal to, and on the diagonals I'm going to put my eigenvalue of 3 and -3 there. Yeah, so on the leading diagonal we're going to have that there, and that's going to be 0, 0 there. Okay, for matrix U I'm going to have, and I'm going to put in my eigenvectors, so we need to be careful that we put the corresponding eigenvector for this eigenvalue here, and that one there, and then I'm going to have the inverse of U, which is going to be so the inverse of this here. So if I swap those two around and make those negative and times it by the reciprocal of the determinant of this, so the determinant's 2, so I've got a half out here, and that's going to be 4, 1, so that's going to be -2 and -1 there. Okay, so so those are all the bits that I need for part A. For the first part of part A. For the second part of part A, I need to determine the matrix M. So remember, the matrix M is going to be U, the product of U, D, and the inverse of U. So I'm going to go ahead and multiply those out. So I'm going to have M is going to be equal to a half of 1, 2, 1, 4, 3, 0, and I've taken this half over here, so I'm just going to have 4, -2, -1, 1. Okay, so I'm going to multiply this out, so I've got a half of, and I'm going to find the product of these two first, so I've got 3 -3, 6, and -12, and then I've got times that by this, and then I'm going to find the product of these two, and that's going to give me a half of 12 plus 6, which is 18. I'll do this quickly. That's going to be 48, -6, and -18, which is going to be equal to 9, 24, -3, and -9. Okay, right, so so that gives us the matrix M, and that's going to be that part there. Okay, so part B says given that n is a positive integer, use the result m to the power of n is equal to u times d to the power of n times by the inverse of u. We're going to show that when n is even, we get this result, and when n is odd, we get this result. Okay, so I'm just going to tidy this up a little bit. Part BI then, I'm going to write, okay, I'm going to write m to the n in the form u d to the n is u and inverse of u. So we know that u from before is that, so 1, 2, 1, 4, and we've got d to the power of n, so I'm going to raise each of the elements here to the power of n. Because we know that n is even, that means that that's going to stay as 3 to the power of n, that's going to stay in 0, 0, and if I take a negative number to an even power, it's just going to make it positive, so I would write that as 3 to the power of n, because that's always even, that's always going to be a positive result. So I put that there, and then I've got my inverse of u, which is going to be a half, so I'm just going to stick the half here, times by this here. Okay, right, so I'm now going to go ahead and multiply this out. So this is going to be equal to a half, and I'm just going to make it a little bit bigger so we can see clearer what's going on. So I'm going to find the product of these two first, so because I'm multiplying this by 3 to the n, that means that that's going to become 3 to the n. That's going to be 2 lots of 3 to the n, and that's going to be 4 lots of 3 to the n. Okay, I'm just going to make that up a bit. Okay, and I'm going to times that by this here. Okay, so that's going to make that equal to a half of, and if I multiply this out here, I'm going to get, so row 1, column 1, so 4 times 3 to the n, take away 2 times 3 to the n, which gives me 2 times 3 to the n. Over here I've got row 2 times by column 1, so I've got 8 times 3 to the n, take away 8 times 3 to the n, which is just 0. Over here, so this is row 1, column 2, I've got minus 3 to the n plus 3 to the n, which is 0, and over here, row 2, column 2, so it's minus 2 times 3 to the n plus 4 times 3 to the n, which is 2 times 3 to the n. Okay, so and that's actually going to be equal to, well, if I take 2 times 3 to the n outside of this, I'm actually going to get 3 to the n times by my identity matrix, which I can write as 3 to the power of n times I. And there you go, so there's our first part done. I'm just going to tidy this up, and then we'll move on to the second part. Okay, the second part can be started in the same way as the first part. So over here, okay, we started off by writing our m to the power of n in terms of this here, so we're going to do that again. So this time we're going to have 1, 2, 1, 4, and the thing that's going to change this time is our d to the power of n. We're going to have 3 to the power of n 0, 0 here, and then if I take the negative 3 to the power of n, and I know that n is odd, then we're always going to get a negative solution, so I would go ahead and leave that as the negative 3 to the power of n, and then I times that by the inverse of u, so I'll just put the half there, and we've got negative 1, 1. Okay, so I'm going to go ahead and I'm going to multiply those bits together, so I've got a half of, and that's going to be 3 to the n plus 0, so that'll be 3 to the n, that's going to be negative 3 to the n, so 2 times 3 to the n, and we're going to have 4 times there we go, and I'm going to times that by this here. Okay, do the next product then. I'm going to write it a little bit bigger so we can be clear. So I've got 4 times 3 to the n plus 2 times 3 to the n, which gives me 6 times 3 to the n. This one here, I've got 8 times 3 to the n plus 8 times 3 to the n, which is going to give me 16 times 3 to the n. And over here I've got minus 3 to the n, minus 3 to the n, so that's going to be minus 2 times 3 to the n, and finally over here I'm going to have minus 6 times 3 to the n. Okay, and I'm going to half all of this, so that's going to be 3 times 3 to the n, that's going to be 8 times 3 to the n, minus 3 to the n, and minus 3. Right, okay, so the format we want this in though is we want it in the form 3 to the power of n minus 1 times by m. So I'm going to replace 3 to the n with, well, let's just over here, I'm just going to write down that 3 to the n is going to be equal to, and if that's going to be the same as 3 times 3 to the power of n minus 1, okay, because if I did 3 to the power of 1 times by 3n to the minus 1, I would add the powers together and that would give me 3 to the power of n. Okay, so I'll put the power there just so you can see that the sum of those two gives us 3 to the power of n, so this is going to be the same as this over here. So I can use that now, and I can substitute my 3 to the n with this here, 3 times 3 to the n minus 1. So so that means m to the n is going to be equal to, and that's going to be 3 times 3 times 3 to the power of n minus 1, which is going to be 9 times 3 to the power of n minus 1. This is going to be minus 3 times 3 to the power of n minus 1. That's going to be 24, and that's going to be negative 9. Okay, and well, we can take our 3 to the n minus 1 outside because it's a common term in each of these, so that's going to be equal to 3 to the power of n minus 1 times by 9 And there you go. And you might notice, you should notice that that is the same as our matrix M over here. So we've now, we can now say, we can finish off by saying, well, that means that M to the power of N is going to be equal to 3 times N to the power of minus 1, and that's the same as M, so times by M, and there you go. Okay, I hope that was clear, and I'll see you next time.